Well, hello and welcome to Ms. Robinson back here with yet another brand new exciting video, and we're going to be looking at triangle inequalities. This should be pretty quick and painless. I'm going to start with the triangle inequality theorem. We'll do several examples on that and look at what's called angle and side ordinance. Ordinance just means how we rank things, but we'll look at it when we get to it. Let's go straight into this. The triangle inequality theorem states this, guys. The sum of any two side lengths of the triangle is greater than its third side length. Plain and simple. If you have a triangle, the only way for it to be a triangle is if I take any two side lengths of the triangle, and when I add them, it's always greater than the third side of the triangle. Which two sides am I talking about? Any two sides. If I take side lengths A and B, and I add them together, it must be greater than C. If it's not greater than C, it's not a triangle. You'll see what I mean by this when I do some example things. If I took B and C and added them together, they'd have to be greater than A. And if I took A and C and added them together, they would have to be greater than B. This is the only way that any of this is possible. Now, it seems most likely for us to test the two shortest sides and add to make sure that they are greater than the third side, which would be the longest side, of course. But it is worth mentioning all three of these for another set of problems that we try, and we'll make sure to get to those. Here's kind of a, this isn't a proof, here's just kind of an indicator of what I'm talking about here. Let's say I have some side length of a triangle of what I want to make a triangle like this, right? And I have like another side length that's right here. Well, this side length needs to be long enough to be able to attach to it. You know what I mean? You guys must know the segment addition postulate, that when I add two, let me do it this way. Let me lay these things down flat and say that two of these basically add up to make the whole thing right here, right? This plus this equals this as far as length goes, right? Now that's only if those two were touching as if they were on flat ground. But guess what triangles do? They stick up a little bit. So this triangle sticks up a little bit here. And if you want this thing to stick up and attach to it, and you want it to touch that one, you want it to hit there, it needs to be long enough. It needs to be long enough. It needs to be greater than this side here in general, right? I need to make this greater so that when I rotate it and I take this one and I make it maybe a little greater, and when I rotate it, they can actually connect. That's a dumb example that I'm talking about here, but these need to be long enough to connect. Otherwise, they end up going, can't reach, right? They need to be long enough. That's it. They need to be long enough. And that's the take-home message of what I just did. That was really stupid. That's the point. All right. Anyway, I missed a home run. Okay. Anyway, use the triangle inequality theorem to tell whether a triangle can have sides with the given side lengths. So in this example number 1, I have side lengths 4, 8, and 10. I'm not going to draw it, so to speak, but I need to see, by doing the triangle inequality theorem test, I need to see if 4 plus 8 is greater than 10. Yeah, 12 is greater than 10. So that seems to already check out in a way. Now you might want to double check some of the others. You can check and see if 4 plus 10 is greater than 8. Okay, 14 is greater than 8, that works. And if 8 plus 10 is greater than 4, okay, 18 is greater than 4, that checks out. As you can tell, guys, it probably seems to be worth it to only test the two smallest sides and see if they add to become greater than the largest side right there. This is the only one that was probably worth testing as long as you know the smallest ones, because clearly, look, 10 itself is already greater than 8. I mean, how else are you going to do it, you know? So already, obviously, those will work. So I'm just going to test the smaller sides against the longest side. Let's check out number 2, 12, 4, and 7. Let's see if 4 plus 7 is greater than 12. Well, that 4 plus 7 is 11. 11 is not greater than 12, no siree. That does not work. So this, you cannot make a triangle out of this. The example like I did before, if this is length 12, here's my 4, here, well, how about here's my 7, and here's my 4, and they can't touch. There they are. All right, number 3, 7, 8, and 9. Well, is 7 plus 8 greater than 9? You betcha. 15 is greater than 9, therefore. And remember, I tested the two smallest side lengths there. Last one, number 4, 24, 8, and 30. Again, worth it to try the two smallest sides here. 24 plus 8, is it greater than 30? Well, 24 plus 8 is 32. That is greater than 30. That one also seems to check out. So the only one that couldn't make a triangle here was this guy right here. too small on the two shorter sides to reach. Okay, if two side lengths of a triangle are known, if you only know two of them, the third possible length range can be exercised by testing all three inequality sums. So you saw the triangle inequality theorem. You saw that I did a plus b, b plus c, and a plus c to test to see if they're greater than. I'm going to do all three tests here to look at a range of what the possible values are of the third side. You'll kind of see what I mean when we play with it. Here, the largest and smallest positive lengths would represent its lower and upper bounds. Once you see an example, you'll know what I mean here. And the examples here, find possible values for the length of the third side given the other two side lengths. Let's say I had a triangle where I knew that one length was 10, the other was 12. Now this third side here, guys, here's the idea. We don't know whether this third side x needs to be the longest side, the shortest side, or the middle side. And it doesn't matter which one, it doesn't need to be any of them. It can be a range of them. Can x be the number 7? Can it be 7 inches and it still be a triangle? Can it be 15 and still be a triangle? What is the range of x values that we can choose? That's why we should set up all three sets here. We should make a set where 10 plus 12 is greater than x. We should create a setup where 10 plus x is greater than 12. And we should create a setup where 12 plus x is greater than 10. And let's see what values of x we're considering within this range set by solving for x in these inequalities. When I add 10 and 12, I get 22. This says 22 is greater than x. But if you've ever been with me with inequalities, I always say write the inequality on the left. So flip this, x less than 22. This is potentially an upper range for what we're looking at here because it's a less than. 10 plus x is greater than 12. If I subtract 10 from both sides, I'm going to get a statement that says x is greater than 2. By the way, these are inches. And 12 plus x is greater than 10. I subtract 12 from both sides, I get x is greater than negative 2. So, okay, there's kind of a range within here. Understand that when it says x is greater than negative 2, I don't really know if x can be greater than negative 2. There's kind of an issue when we're looking at this range right here. Because 12 is already more than 10, what you'd be looking at is a triangle where, say, if this was the length 10, 12 is more than it. See how it exceeds it right here? There's kind of a different thing going on here that we can't really talk about. We got to negate this one. If there's a negative value at play, ignore it. See, for x needs to be a certain length. It needs to go back and reach the 10, right? How far back does it need to go? That's the answer right here. X needs to at least be greater than 2 inches, that is. So x needs to be greater than 2 inches. Well, don't want it red. X needs to be greater than 2 inches, but it needs to be less than 22 inches. Any more than 22 inches, the 10 and 12 can't connect, and any less than 2 inches, the x can't connect the 12 to the 10, right? If x is less than 2 inches, right? 10, 12, less than 2, right? Sorry for making this sound all the time. So my range for x, this inches amount, needs to be between 2 inches and 22 inches. And that's setting it up with all three in the triangle inequality theorem. One and the other and the other. That's why it's worth kind of noting all three. Let's try this with number 2. In number 2, let's test x plus 9 is greater than 18. Let's test x plus 18 greater than 9. And let's test 9 plus 18 greater than x. Sorry for the room, or lack thereof. Let me scooch some things over. All right, x plus 9 is greater than 18. Subtract 9 from both sides. X has to be greater than 9. All right, that's one of the things, or at least that's a setup for this. X plus 18 is greater than 9. Subtract 18. X is greater than negative 9. Oh, one of those oopsies. We're going to kind of leave that out. And 9 plus 18 is greater than x. That says 27 is greater than x. But of course, as a rewrite, flip this over. This would say x is less than 27. So when it comes to inches on these guys here, I thought I was going to use different units like feet. Oh well. X looks like it needs to be greater than 9 but less than 27. So as a compound inequality, x is between 9 and 27 inches right there. That is, once again, its range. Any less than 9 or any more than 27. Sorry, excuse me. Even if it's 9 or 27, it cannot be a triangle. It just doesn't meet the the parameters that is needed for it. I wish I could draw these to show you, but for time's sake and everything else, I will not. Okay, so we've done the triangle inequality theorem, and now let's look at angle and side ordinates. This will be very, very brief. Let's take a look here. In a triangle, the largest angle is opposite the largest side. By the way, I can swap that. The largest side is opposite the largest angle too. And the smallest angle is opposite the smallest side. Equal sides yield equal opposite angles. This part here is the reason that isosceles triangles have equal opposite base angles, and equilateral triangles are also equiangular. Because if all sides are equal, that means all angles are equal, because the sides opposite are the same. And this is also the reason the whole largest angle, largest side and stuff, this is also the reason the hypotenuse of a right triangle is always the largest side. In a right triangle, the largest angle is the 90-degree angle, because these are acute, and the opposite side is right there. So it's going to be it. Yeah, how do you do opposite sides versus opposite angles? Opposites are just pointing right across. What's opposite the 45? This side. What's opposite the 70? This side. Opposite the 65? This side. That's how opposites work, guys. Opposite sides to opposite angles like that. So let's go ahead and crunch through this. Which is the largest angle among all three of these? Angle A is the largest angle right here. So largest angle is A. Guess what the largest side will be? This side over here. What do I call it? Side BC. So BC is the largest length right there. It's the one that doesn't have the letter A, because it's opposite of A. What's the second largest here? The 65B. What's opposite the B? Side length AC. Side length AC is less than side length BC right there. And then the last one, the smallest one, it can go smallest to largest next time, but smallest one is 45. Opposite the 45 is side length AB right there. Do I know the side lengths? No. If I knew one of the side lengths, I could get them for you. I'd have to use some interesting pre-calc or trig stuff to figure it out. It's called the law of cosines. I ain't getting into that. But this is least to greatest as far as side lengths go. AB is the smallest. AC is the next smallest, and then BC is the largest right there, smallest to largest. Same thing goes right here. The smallest angle is 30 degrees, so opposite that thing will be the smallest side. That one is BC. BC is the smallest in this case. It is less than the 50-degree angle opposite that guy right there is side length AB, and then across angle B, the 100-degree angle is side length AC. I did mention how in a right triangle the hypotenuse is the largest because the other two angles have to be acute. Same for obtuse triangles. In obtuse triangles, only one angle can be obtuse. That means the obtuse angle, opposite the obtuse angle will always be the largest side. And it makes sense, guys. When you look at this, the wider this angle goes, the more that side needs to kind of compensate for it. I think that kind of just makes sense. There's the order in those things going from angles to side lengths. All right. The last one I'm going to do here is draw a diagram, order the angle measures from greatest to smallest in a triangle ABC. If AB is 21 units in length, BC is 14, and AC is 32. Draw a diagram. I'll do a very quick one, not even doing it to scale. Here's ABC. By the way, does this make a triangle? Does 21 plus 14 exceed 32? Yeah, 21 plus 14 is 35. That's more than 32. That works out. All right, AB is 21. BC is 14 and AC is 32. Which angles, how do we order the angles? Opposite the smallest side is the smallest angle. So opposite the BC, let's use different color. Opposite side BC is angle A. The measure of angle A, whatever it is the the one, right? That's going to be less than opposite the 21, which is the next smallest. That'll be angle C. So measure of angle C is the next smallest, and that's less than measure of angle B, because that's opposite the 32. That is the measure of angle B. That's going to be the largest one. Again, I don't know specifically what they are. One thing I do want to mention, and I probably should have mentioned it on the last thing before this one, is that sides and angles do not grow in the same proportionality with each other. What I mean is, if I have one angle that's twice as large as another angle, that doesn't mean the side opposite is twice as large as the other one. You got to use trigonometry to come up with those ratios there. It's a way different gesture, but there it is. And that's the last thing that I'm covering here. That's angle and side ordinates. That'll be it. So guys, thank you so much for watching. Let me know if you have any questions. Take care.